In this video, we will see how to solve a transportation problem by the help of northwest corner method. So as we saw in previous videos that in order to solve a transportation problem, we need a transportation table. In this transportation table, we had different sources like this S1, S2, S3 and S4, and we had different destinations, and we were sending the material from destination from a source to different destinations. Okay, and there were different demands of each destination, and there were different supplies which were coming from each store or each source. Okay, so we will use all these to solve our transportation problem. So let's take an example of a transportation table, and I'll tell you how to use this transportation table to solve the problem. Okay, so what is, firstly we'll see what is given in this question. So it is given that there are three sources from which material is going. So these sources are listed here, S1 and S2 and S3. These are three sources, and we have four destinations, D1, D2, D3 and D4. What else is given is that the source S1, this source of S1 can give 7 units of material. Okay, so this 7 unit of material can be provided by source S1. Similarly, the source S2 can give 9 units of material. Okay, and the source S3 can supply this 18 sources of material, 18 units of material. Okay, so these are the maximum supply which these sources can do. The demand for the destination D1, the total demand is 5 units, which is given here. For the destination D2, the total demand is 8 units, which is given here. For D3, total demand is this, and for D4, the total demand is this. Okay, so these are the total demands and total supplies which are given in the question. Now how to solve this? So in order to solve this, as the name says that this is northwest corner method, so the solution starts from the northwest corner. From this corner a solution will start. Okay, so we will allocate the resources in this corner, and how to allocate the resource we will see. So let's say we will firstly see the demand is 5 units here and the supply is 7 units. Okay, so the lowest among these will be filled in this corner. So in this case, the lowest is the 5. Okay, so we will write 5 here in the northwest corner. Okay, so now the demand for the destination D1 was 5 units, and we see that we have fulfilled the demand. We have provided 5 units to the destination D1. Okay, so hence we will cancel out this whole corner now, whole this column now. Okay, this whole corner will be cancelled out. Okay, so what will happen now? We have given 5 units, and these 5 units came from the source S1, this source. Okay, so now the total supply which this source S1 can do will be reduced to how much? 2 units. Okay, because 5 we have already provided, so there are 2 units left of S1 in this. Okay, now we will come horizontally to the next column. Okay, next northwest corner column which is available to us, which is this, because now the whole this column is not there in use, because the whole demand of the D1 is met, so D1 will not be used. So we will come to the northwest corner of this D2 now. So we'll check now, the demand is 8 and the supply left is 2 now. So whichever is the least among this will be filled. So we will see that the least is 2 now. So this 2 will be filled here in this, and now we will see that this 2 is met. So now what will happen, that this source S1 cannot provide anything now. Okay, this source is 0, so this will not be used, this will be cancelled. I'll use a different ink. So this will not be used, this will be cancelled, because the whole supply this S1 can do, we have already used all this. Okay, so now he'll see the demand was 8 for D1. Now the remaining demand is how much? Is 6 now. Okay, because 2 is already met. So now we will be coming to the next northwest corner which is available now, which is this one in this case, because this row we have cancelled out already because there was zero supply left. So in this corner we'll see, now again checking, the 6 demand is available and the 9 supply is available. So what is the least among this? Is 6. Okay, so we'll fill this northwest corner by the number 6. Okay, 6. So now checking, 6 was required, 6 we have supplied, so the demand of this has already been met. So this corner will be cancelled now. Okay, because we have used this 6, there's nothing left now, zero demand is left, so this will be cancelled out. Okay, now coming to the next northwest corner, which now is this, because all the others are crossed now. This is crossed, this is already crossed, and this is already crossed. So the next available northwest corner is this one. So here, what earlier we had provided 6 resources to this, hence the supply which this can do now will be reduced to 3. Okay, it's 3 now. So again checking the least from the supply and demand, here 3 is the least, so 3 we will fill here. Okay, so how much was required? 3 will be filled here. So how much was required for the demand is was 7, but we have filled 3, so the left demand will be how much? 4 now. Okay, and here 3 we have given, so available supply here is 0 now. Okay, so because this is 0 now, we will cancel out this also. Okay, now we will proceed to the next available northwest corner, which now is this. Okay, so what will now, one more thing, that at every time you can check if you are going right or wrong, is that if you will add this 14 plus 4, it will always be equal to the left supply, which is 18. Okay, or supply which is left 18 will be always equal to the left demand at every time. Okay, this will tell you if you are going right or wrong in the question. So anyhow, so again by following which one is the least supply or demand, 4 demand is left, and here 18 supply it can provide. So what is the least is 4. So 4 will be filled in the northwest corner. Okay, 4 will be filled here. Now see, this has been met and this came out to be 0. Okay, and here how much? So this column will be cancelled out, and here 4 was there, so how much remained here is how much? 14. Okay, so now the available northwest corner to us is just this one, last one, this. So 14 was required here, 14 was the demand here, so we'll fill the 14 here, and our all demand and all supply constraints are met now. Okay, so we have provided the material to different sources in a way so that our cost is minimum now. So how to find the least cost? So as I told earlier, that this, let's say, see in the first column, I'll highlight this. See here, this 19 was the unit cost which was required to send the material S1 to D1. Okay, a unit material will be sent in, let's say, 19 rupees, and how much material you are sending is 5 units of material. Okay, so the total cost which will be now for sending 5 units of material will be 19 multiplied by 5. Okay, here what will be the cost? It will be here in the second column, it will be 30 multiplied by 2. Okay, in this it will be 30 multiplied by 6. In this it will be 40 multiplied by 3. In this it will be 70 multiplied by 4, and in this it will be 20 multiplied by 18. Okay, so an easy method to remember this is just multiply the cost by the northwest corner figure which is filled in the northwest corner, multiply that and add all these. This will give you your profit function, which is z. So okay, so in this case the profit function is this. Okay, so I have multiplied the unit cost by how much material you are sending, and you will find your ultimate solution. Okay, so this is the way to solve a transportation problem by using a northwest corner. Hope you understand this. If there are any doubts, you can write, you can email to me anytime, and I'll explain this.